Hi, this is Abdul Aziz Khan. So this is lecture 22 of Basics of Microwave Propagation. And as we have started the refraction part of microwave, and in the previous lecture, I take you to the very physics of it. Let's go further. Let's see the mechanics of wave refraction. We will try to learn something about wave refraction. So in normal atmosphere, the atmosphere which is around us, the temperature, humidity and pressure in the lower atmosphere, I mean the atmosphere that we are part of it basically decreases linearly with increased altitude. I mean, or if I try to make it a bit more clear, like for example, if you are standing on the land, then the temperature and humidity and pressure, they have a bit higher value. But if you go towards some hilly area, if you climb up somehow, because as you know that when you go in the hilly areas, we say that the temperatures are also low, the humidity is also generally low, the pressure is also low in there, those areas. That's why when you are cooking something and when you are boiling something, it takes a bit more time, because there is the natural pressure is lower as you go up, and when you go very high, then the temperature and humidity and pressure, they all decreases to almost zero, and then you cannot survive, I mean, in very high climate. Like for example, if you try to go on the any of the peak, the 8 or 10 peaks which are more than 8,000 meters high, um, you know that they are not very easy. You have to take your oxygen with you also, because sometimes the atmosphere goes very bad and oxygen becomes very low in that area, because there is no atmosphere. I mean, there are no more gases, so every gas is low, so oxygen is also very low. So as you go high, these things, they decrease with as soon as the height increases. So the corresponding linear decrease in refractive index also happens, and the velocity of microwave traveling through the atmosphere increases as the refractivity index decrease. So as the atmosphere becomes thin and thin, like we have a word like there's thin air. So thin air is really thin, I mean, because it is void of gases. There are no more gases. So as it becomes thin, it becomes more similar to the vacuum. I mean, it like we are changing from a normal atmosphere and we are going towards vacuum. So it is something in between. So the velocity of waves, because we know that the velocity is basically the highest in vacuum, because there is no abnormality, no any other thing. I mean, the light travels with it's the highest speed. So as we go up, the velocity of microwave increases, because the refractivity index, it goes low. So this is some mechanics of refraction, that as you go high, what happens. But as these wavefronts, they pass through a normal atmosphere, and because of this, we don't feel it very well. So it starts bending slightly downward in a uniform curve. That's why I hope when you have listened, you know that when we send a microwave or when we send a wave, it bends from the atmosphere and it comes back. I mean, so this is the reason that why it comes back, because the refractivity index is changing and it's decreasing. So every decreasing is bending it, and it bend, and then it come down and then hit the surface again. So I hope that this mechanics now, which you may have learned in when talking to someone and when reading, or so you now you should have some better idea that why it happens. Because even though we say that the space or the environment around us is uniform, but it's generally thought of as uniform, or average of it is a uniform number, but it is not uniform. As soon as you start going up, the number changes, and then there are some anomalies that we will discuss that can come inside. But in future we will discuss that. But hopefully this point should be now very clear to you, and I hope that as we are trying to make a foundation, if you are having any trouble in understanding this point, or or the previous one. So it's better that you communicate with me, you make a comment on this so that I can go in a bit more detail for you if you are having some problem in learning it. But as a nutshell, just remember that the refractivity index or the atmosphere around us, it's a bit denser near the ground, and as soon as we go higher in altitude, it becomes a bit thinner. So there's a slight gradual and constant change. It changes from a high refractivity index to a lower refractivity index on every level or every layer. So the wave, when it passes through it, it starts bending and then it bounces back to the earth. So hope to see you in my next video. Goodbye.